Alright, so our first step to solve this inequality is to get y by itself. So we are going to divide both sides by 2. So you divide everything by 2, and you get y is less than or equal to 3 halves x minus 3. So then our first question is, will the boundary line be solid or dotted? So for that, if it's solid, that means we have a less than or equal to or greater than or equal to. For a dotted line or a dashed line, it's less than or greater than. Here we've got less than or equal to, so it's going to be a solid line. Then we want to graph this line, so we're going to start at -3 for our y-intercept and go up 3 to the right 2. Up 1, 2, 3 to the right 2. I would do this as many times as you're able to help you get a nice line on formative. And then we know it's a solid line going that direction. For number 3, it says choose 2 points, one on each side of the line, and plot them. So we want to choose a point that's on the left side and a point that's on the right side. The first point you should always choose if possible is 0, 0. The only time you couldn't choose that if it was on the line itself. So our left point will be 0, 0. Our right point, let's choose something easy like 4, 0 would be our other one. Now what we do with these points is we plug them into our inequality over here and see which one comes out to be true. So the first one, we get 0 is less than or equal to 3 halves 0 minus 3, and you get 0 is less than or equal to -3. That is a false statement, so that's not the one that we're looking for. Then we'll plug in 4, 0, so we get 0 is less than or equal to 3 halves, plug 4 in for x minus 3. We get 0 is less than or equal to 6 minus 3. 0 is less than or equal to 3. That's a true statement, so we've done number 3. And now what that helps us do is then number 4 is shade our graph. We want shade on the side where this was true, and where that was true was at 4, 0, which is this point here. So we're going to shade everything beneath the graph. And that's how you complete the 4 steps for these problems.